I'm gonna log off. Just check to make sure you can hear me. That's the one thing I'm not sure about.
Okay, I'm going to mute Raf so I can listen to her on YouTube, and people don't hear this.
Can you hear me? Can you see me? Am I good to go? Let me also pull up my comments so I can see them. Although I kind of need to make sure you can hear me first. Hello, 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 hello. Can you hear me? Can you hear me? Can you hear me now? Another day. We got this. I'm going to show you today the tasks. Yay! Yay, success. First bit of success is just getting started every morning, making sure that we're all here, can hear. And I'll wait, I'm a little bit early, I'm like 3 minutes early, so let's just chat for a little bit. As you come in, you can let me know that you're in class, say, hey, I'm here today. Yeah, it is hard to read. He did it in orange. I think he thinks we can't read his handwriting and he wants me to rewrite it every day, and I'm not rewriting it every day. So, it is hard to read. It says, when the sun has set and the light has disappeared, a new day will come. Very deep there, some deep thinking. We got some haikus going on. When the sun has set, you can type it in there. When the sun is set and the light has disappeared, a new day will come. Feeling it super deep. Oh man. End of the week. Day 4, virtual learning. We've made it through week 1, and then after today you'll be able to finish up your tasks, get everything turned in. We'll be in good shape. As you come in, why don't you let me know you're here to say hi, or hey, I'm in class, or hey, I made it, or what you doing today? Oh, just empirical recognition that the sun comes up every day. Yeah, that's all it is. That's all it is. That's exactly what it is. The sun comes up the next day. I think maybe my son was feeling a little dark yesterday, and he needed to remind himself that the sun's going to come up tomorrow. So, what it says is, when the sun is set and the light has disappeared, and the light has disappeared, a new day will come. When the sun is set, hey, there's Bo this morning. And Zoe, yay! Ready to go. Me too. Ready to get started. Let's do this thing. Get ourselves going. Yay! Up and going this morning. Got a task or two, I got a thing or two ready to go. And the light has disappeared, a new day will come. Yeah, that's it. You got it. That's pretty fun. When the sun is set and the light has disappeared, a new day will come. A new day will come. It'll be all right. Everything's going to be all right. Everything will be all right. It could just be basic, the sun will come up, or it could be like deeper than that. Could be deeper than that. Think deep. Hey, there's Amani. Yay, Amani. Another one here. Yay. I can't do SpongeBob or Squidward. I can't do voices. I need somebody else to help me out. You do it. Read it in a SpongeBob voice. Oh, I get it. I'm ready. I got it with you. I'm with you now. A little slow on this early Thursday morning. I've been up way too long today. I was on Remsen's hours instead of my own. All right, it is now officially 9:30. I'm gonna go ahead and get started. And then anybody who's missed this beginning part can always go back and rewind it later and watch to see how we started. And today, our job is to do the task. I'm just going to show you how we do task 1 and task 2. So then you can do those today, turn in everything that you've done the week, and be done and have the weekend off. That's the plan. And then I can start grading and get you your feedback. So the first thing you need for this task is some sort of container. You know, a kettle, or a coffee pot, or a cup, or just a bucket. It doesn't matter what it is. Pick some sort of container. I'm going to use a kettle. All right, that's number 1. You just need a container. Grab a container. Number 2, you need items that you can make 2 groups in that are similar items that you can make 2 groups of. So for instance, pens and pencils. Or here I got some PlayStation 2 boxes and some PlayStation 4 games. Something similar, there's 2 groups. I'm going to use M&Ms. That's my plan, use M&Ms. But just pick any old items around your house. Look for something around your house that's similar to one another and yet you can make into 2 groups. Okay, that's the plan. Okay, next. All right, next. I'm going to use M&Ms. So I'm going to open up my M&Ms. And what you want is 8 of one item and 2 of the other. So let me grab this back again. Pretend I was using the pens and pencils. I might do 8 of my pens, 1, 2, 3, 4, 5, 6, 7, 8, and 2 of the pencils, so that I have a total of 10 items, or maybe 8 PlayStation 2 games and 2 PlayStation 4 games, okay? So you need a total of 10 items, 8 of one and 2 of the other. So for my M&Ms, I might pick red to be one group and not red to be another. So I got red and not red as my 2 groups. So I would do 2 red M&Ms. Can you see the table? Maybe not. 2 red M&Ms and then 8 of the others. So 2, 4, 6, 8 of the others. Okay, the table's not quite high enough. Either that or my camera needs to go low enough. Oh darn. Okay, anyway, so you got 2 and 8. All right. So those are the things you need. A container, items that make 2 groups, and then you're going to do 8 of one and 2 of the other. I'm going to do a little bit different numbers just so that I'm not doing exactly yours for you. I'm going to do a little bit different numbers. Instead, I'm going to use 3 of one, 3 of one, and 7 of the other. So 4, 5, 6, 7. Okay, so my numbers are a little bit different than yours, just because so I'm not doing exactly your homework for you or the task for you, but it's going to be really similar. All right, but you're going to have 2 and 8. Then you also, before you put it in, decide which is which. So the 2 is your black, and the rest of them are your white. So in my case, my red are my black, and the rest of them are my white. Or maybe I should do, maybe I should just go ahead and make it black so that we're not confused. 1, 2, 3, 4, 5, 6, 7. So I've got 7 here that these are going to be white, and these are going to be my blacks. And mine's a little bit different. You're going to have 2 and 8, but I've got 3 and 7. Okay, then what you do is you just put it inside the container. So I'm putting all of my 10 items in my container. And then we're going to find a way to select them randomly. So, maybe all you're doing is you're just reaching your hand in and picking one out. Or maybe you find a way to pour it out. So I'm going to do that. I'm going to pour mine out, because I have this kettle here where I can pour it out. I'm going to take it out and I'm going to look at it. And I'm going to choose 3 of them. So in task 1, you're supposed to choose 3 of them without replacement. So I'm going to do that exact same thing. I'm going to take 3 of them out. So 1, if you were doing it with replacement, you'd put it back in and then you take it out again and look. Okay, but without replacement, I'm just going to take out 3 of them. 1, 2, 3. And I'm going to look at them. And then I'm going to count the number of blacks that I've got. Okay, so let's start. I'm actually going to skip down to your 9th thing that you're supposed to do on the homework, because I want to, even before I begin, I want to kind of think about what's going to happen in this experiment. By the way, it says, when the sun has set and the light has disappeared, a new day will come. So, the sun will come up tomorrow. Okay. All right, so there's your haiku for the day. All right, so let's just think about what we can do. If I'm taking 3 things out of there. So I've got this bucket of stuff. I'm going to pull out 3. I'm going to look at them. I'm going to put them back. And what I'm doing is I'm counting the number of blacks. So if I'm taking out 3, what's the minimum number of black marbles or M&Ms or items that I could get? What's the smallest number of black items that I could get? If I'm pulling out 3, choose 3 without replacement. Okay, so this is task 1. Task 2 is the same, only it's with replacement. But we're going to look at the one without replacement first. So here we go. What's the smallest number of blacks that I can pull out? If I'm going to pull out 3, look at them, and count how many blacks I have then, what's the smallest number of those black M&Ms that I could get? I could get 3. That is one thing I could get. I don't think that's the smallest, but I could get 3 of them. I'm going to put that on there. So this X here is the number, let me do a better job of this. The number of black that I could get. I agree with Ann Cara that I can get 3. How many else could I get? 0 is the smallest. Good. I can't get 0. Good, Courtney. I could get 0. How many else could I get? Okay, so that 0 is the smallest and 3 is the biggest that I could get. What else could I get? However many else could I get? If I'm pulling out 3 and looking at them, how many black could I get? So I could get 0, or I could get 1, or I could get 2, or I could get 3. Okay, Mr. Simpson, I will. All right, so this is going to be our number of black, the number of blacks that we get. That's our random variable. And we call that X. Our random variable then is X. Perfect. Okay, so we can do 0, 1, or 2, 0, 1, 2, or 3. So when you're doing your probability distribution or your frequency distribution that you're making, you're going to need 0, 1, 2, or 3. I think in my notes or in the instructions to you, it just has 0, 1, 2. But we can also get 3, so we need a 3 in there also. Hey, Adam. If you're in here, you should let me know in chat. You should be like, hey, I'm here. I showed up. Okay, so now, without actually doing the experiment yet, I want to know what is the probability then that I get 0? What's the probability that I get 0? So again, what I'm doing is I'm going to choose 3 without replacement, and I'm going to look at them. So let me show you again. I'm going to take my container that has my 2 different things in it. I'm going to open it up. I'm going to take 3 out of there. 1, 2, 3 things out of there. I'm going to look at them, and I'm going to count the number of black balls. So from our classical probability the last 2 days, how could we get 0 balls? How could we go about getting 0 black balls? What would we have to get out in order to get 0 black balls? So first thing we want to do is use the words. That's the first task. Don't try to put numbers with it yet. Remember, when we're doing the probability, we want to first use our words. And we want to include those words like and or to help us with the probability. So in order to get 0 blacks, I would have to get a not black and not black, or you could call it instead a white, because yours are we're dividing them up into 2 categories, white and black. So yeah, good, Courtney. But remember, Courtney, we want to use the word and in there. So instead of saying getting 3 white balls, what we want to do is say white and white and white. So white and white and white. So Zoe, let me explain again. Let me back up and make sure that everybody's with me. So let me back up just a minute. First thing you need is a container. That container can be anything. It can be a kettle. It can be a bucket. It can be a coffee pot. It can be a coffee cup. It can just be any old container that you have around your house. Then you want 2 different items that are similar. So for instance, maybe pens and pencils, or maybe PlayStation games, so that you've got PlayStation 2 games and PlayStation 4 games. You know, something around your house that's similar, but you can make it into 2 groups. In my case, I'm using my M&Ms. I just opened up a bag of M&Ms. I'm using M&Ms, and I can divide that into 2 groups so that I have, one color is one group and the rest of them are another group. So just find something around your house that you can split into 2 groups. Then you need 8 of one of the groups, and you're going to call those 8 white. You need 2 of the others that you're going to call black. Good. Priscilla used rocks and labeled them. That's perfect. That's perfect. Here, this could be my white, and this would be my black. So, you just need 8. You just call it white and black. All right. So I'm using M&Ms, and I have different colors, and then I've got black, and then all the other ones I'm calling white. In addition to that, I'm using a little bit different numbers. You're going to do 8 and 2. I'm using 7 and 3, just so that I'm not doing your exact example for you. You have something to do. So, I know, right? That's the best way to do it. You can do, I thought it said that you were in the bathtub, Adam, as you're watching. That would be like the ideal way to have Flash, right? Relax in the bathtub while you're watching The Simpsons. Okay. But that's not what it says. Okay, so anyway, so now what we're doing first is I actually skipped down to number 9 on the task, which is to make the classical distribution. So this we've been doing the last 2 days. We've been working on making these classical probabilities. So it's the same thing that we've been doing in the past. And we said that if we're drawing it 3 times without replacement, that we could get 0 blacks, 1 black, 2 blacks, or 3 blacks. All right, so I asked, how can we go about getting 0 blacks? Because our first job with probability is just to put it into words. And so we did that. We put it into words, and we said, well, in order to get 0 blacks, we have to get a white and a white and a white. And remember that when you are writing it out, you want to make sure that you're doing each note. On the first draw, what would I have to get? And on the second one, what would I have to get? In other words, you're using those conjunctions of and or, just like you did on the first assignment, that day 1 classical probability. You made sure to use the words and or on your assignment. Okay, so now I'm going to do the classical probability for mine. Now remember, I have in my example, I have 3 blacks and 7 whites. But you're going to have 2 blacks and 8 whites. So yours will be a little bit different than mine, just a little bit. Your numbers will be just a tiny bit different. But basically, they're going to be the same other than that. Okay, so in order to find the probability of mine, now that I have it in words, in order to find the probability that I get 0, what I do is find the probability on my first draw. So what is the probability on my first draw that I'm going to get out of a white? What is that probability? Well, there are 7 whites out of a total of 10 M&Ms in there. So my probability is 7 out of 10. Now, yours will be a little bit different, but mine's 7 out of 10. The and tells me to multiply. If I get a white out on the first one, because it's without replacement, I no longer have, so let's just do a little bit of it. Let's just show you what's going on here. So, you know, I'm taking one out, and sure enough, I got a white one in, I got a white one out. So now, what's the probability I get that second white one out? How many are left in there? How many whites are left in there? Now there are only 6 whites in there out of a total of 9 M&Ms. Good, y'all are doing great over there. Keep commenting. Y'all are doing great. All right, so now I'm going to take another one out and look at it. Oh, that one's not going to count as 0 blacks because look, I got a black. So that one would not be this white and white and white. But in order to give me another white, the probability, so it was a 6 out of 9 chance, and I failed that time. But to get another white, it would be 5 out of 8. You're exactly right, Bo. 5 out of 8. Yeah, y'all have got it. Good. Okay, so what is the probability then that I get 0 blacks? Well, now we just multiply to find out. I'm going to simplify first. So notice that 5 goes into 10 2 times. 6 has a 3 in it. And 9 has a factor of 3, so I can simplify that to 2/3. Then also, here I'll go ahead and write that out. So I have, what I have so far is 7 halves times 2/3 times 1/8. But do you see this 2 and that 2? Those guys can go away. So on top, I'm just left with 7, and on bottom is 24. So the probability that I don't get a black is 7 out of 24 times. If I do this experiment 24 times, if I do 24 trials of it, then I would expect 7 of them for me to get no blacks. That would be my expectation. It doesn't mean it'll happen, but that's the expectation. Okay, so we've done our 0. Now your numbers are going to be a little bit different because you're going to have 2 blacks and 8 whites, but you kind of get the idea. Then, before we find out in order to find out the probability I get 1, Now we're going to find out the probability I get one black. And in order to find that out, first we want to put it in words. So how can I go about getting out one black? What would I have to draw to get out one black? Think about those words with the and the or in between them. So on the first draw, what could I get out in order to end up with one black? How about, I'm going to put down one while I'm waiting on y'all's comments to catch up. So I could get the black on the first one. If I get the black on the first one, then my other two draws, I'd have to get and a white and a white. I would have to get a black and a white and a white. Or is there another way that I can get this? Just one black. Yeah, you're right, Bo. Perfect. A white and a black and a white. Good, Amani. A white and a black and a white. Is there another way that I can get just one black? I like it. So we got a white and a white and a black. And that's all three ways that I can get it. Great job, guys. So now I just put the probability, now that I have the words with it, now I'm just putting the probability with it. So what is the probability I get my black on the first draw? Well, there are 3 blacks out of 10. And tells me to multiply. I'm without replacement, so I'm going down each time. So I'm going to do 9 and then 8. How many whites are in there? Well, I haven't taken a white out, so I have 7 whites still. But now I've taken a white out, so now I just have 6 whites left. Or, so that tells me to plus. So now that I've got those words down, now I'm just adding the probabilities to it. So a probability of a white on the first draw is 7 out of 10, because there are 10 marbles, or M&Ms. And, well, I haven't taken out a black, so it's 3 out of 9. And it's going to go down because it's without replacement. I did take out a white here, so over here I'm down to 6. Or that last little bit, white is 7 out of 10 and 6 out of 9 and 3 out of 8. Still goes down. Here's my whites, there's my black. Notice that on top, every time it's the same numbers. They're a different order, but it is the same numbers. And the denominator also. So really, once I find out one of them, I could just multiply it by 3. Let's do some simplification. So 3 goes into 9 3 times. Oh, but 3 goes into 6 2 times. And 2 goes into 8 4 times. So I'm left with 7 on top and 10 times 4 on bottom, or 7/40ths. But I know I'm going to end up with 3 of those. This is going to end up being 7/40ths, and this is going to end up being 7/40ths. So I have, add those 3 together, 7/40ths plus 7/40ths plus 7/40ths, or multiply by 3, whichever way you want to do it, and you got 21/40ths. So the probability is 21/40ths for just drawing one 40ths, for just drawing one out of there. All right. Now, we want to draw 2 blacks. So tell me, how can I get 2 blacks? Good, Adam. How can I get 2 blacks? So I've done it with 0, I've done it with 1. Now I'm going to do it with 2. By the way, this is number 9 on your task, making the classical probability distribution. Your numbers are going to be slightly different. Because I'm using 7 whites and 3 blacks, and you're using two blacks and 8 whites. All right, but you told me how I can get, how I can do 2 blacks. I can do what? Oh, good. A black, and a white. Or, perfect. White, black, and black. Or that last one is in the middle, right? So black and white and black. So I've got 3 different ways that I can get 2 blacks. Now I just put the probabilities with it. So again, I've got 3 blacks to begin with. My number on bottom is going to go down because I'm doing it without replacement. Same thing here. My number on bottom is going to go down because it's without replacement. Number here is going to go down because it's without replacement. On top, I have 3 blacks and then 2 blacks. So for every one of my blacks here, I'm going to have 3 blacks and then 2 blacks. 3 blacks and then 2 blacks. Once I've taken out 1 black, I only have 2 left. And then I have 7 whites on all of them. So the numbers are the same. And I love how y'all are commenting, you're saying exactly the right thing, that it's going to do it over and over and over again. So that really once you find out this 3, you just have to find out this probability once and multiply it times 3. So that's exactly, y'all have got this. Great job. Okay, so I'm going to just find out the probability once. I'm just going to do this. We'll just do it right here on bottom. So that this is 1/4. The 3 goes into the 9 3 times. And all I'm left with is 7 on top and 10 times 3 times 4 on bottom. And I'm going to take that probability, whatever this probability is, it's 1, 2, 3 of them. So I'm going to multiply that whole thing by 3. Yeah, y'all, you can't have them, Rimson. They're my students, and this is my, it's interesting that my 11 o'clock class is the one showing up, even though I'm doing it at the 9:30's time. My 9:30 class is not representing. It's the 11 o'clock class that's here. If anybody from 9:30 is here, y'all chime in. Let me know you're here. Because right now all I see is my 11 o'clock class. That's why they're my favorite. That's right, they are. And that's why, because they're here. Where are y'all? Come on, 9:30. Where are y'all? Okay, so anyway, notice that this is 3 because it's 1, 2, 3 of them. And then the probability of this guy sitting right there. So there's the 3, and there's this 3 and that 3. I'm going to cancel them out. So even before I multiplied, I went ahead and just canceled that out. So that I end up with 7 over 40. And you're right, Adam, this is 120, you got it. It's 7 over 120. Now multiply it times 3, and you and I are going to come up with the same thing. Oh, there's Zoe. Zoe's representing the 9:30 class. And that's why Zoe's my favorite out of the 9:30 class. Way to be here, Zoe. So there we go. 7 out of 40 is the probability that I get 2 blacks. Now I'm down to 3. And we're going to do, find the probability that I get 3 blacks. Too much stuff up here. So how in the world would I have to get 3 black M&Ms? So use words first to tell me. How can I go about getting the 3 3 blacks. Perfect, Adam. Now just simplify it. You and I are going to have the same thing. Destiny's here too? Okay, good. So got 2 of them out of that class. Way to be, Destiny. Yes. Got Zoe and Destiny. And then my 11 o'clock class. They're all here. They're great. All right, so the only way I can do that is to get 3 blacks is I have to get a black and a black and a black. Now I'm going to do the probability of each one of those. So there's 10 to begin with, and 9 and 8. I start with 3 blacks, but now there's only 2 in there because I took 1 out, and then there's only 1 in there. And that's the only way to do it. Now, the difference between the with replacement and the without replacement and the with replacement, so in your task 2, you're doing it with replacement, so then your denominators just won't change. Your numerators will, and your numerators won't change because you'll keep putting it back in. So on the with replacement, you're just not going to change your denominator or your numerator. You're going to keep those the same each time. So once you find out the probability, it makes it a little easier to do. You just do the same one each time. Now I do my reduction. So 2 goes into 8 4 times. 3 goes into 9 3 times. Multiply across, and I get 1 out of 1/20. So if I did this experiment 120 times, I would only expect to get 3 blacks 1 of those times. Crazy, right? Okay, this is our classical probability. And notice on here, about how many times should I get this? Well, it's what do I expect? If I do the trial 24 times, I would expect 7 blacks. If I did the trial 40 times, I would expect, 7 times I would get 0 blacks. 0 blacks. If I did it 40 times, 21 times I would expect to get 1 black. If I did it 40 times, I would expect to get 2 blacks 7 times. And if I do it 120 times, I would expect to get 3 blacks just 1 time. Oh yeah. Then there's that whole, you've been dealing with the complement. So if I added these all up, they better add up to be a nice pretty 1. It should be 100% of the time I'm going to get either 0, 1, 2, or 3. And then thinking about the complement, if I said something like at most 1, or at most 2, we'll do at most 2. At most 2, well that means if I can have at most 2 cups of coffee, well then I better drink 0, 1, or 2. So at most 2 would be these guys. So then the complement of at most 2 would be 3. So on one of those assignments you were dealing with at most and at least. And next week we'll deal with this some more. So you want to know about this complement thing and how to use it. And if we were to add this plus that, if you added this together and found that sum, added it to this, it would all equal 1. Yeah, in order to add them, we would first have to find a common denominator. And that doesn't look pretty to do. Our common denominator, maybe it's 120? No, probably even higher than that. It's 24 times 5 is, 120. So 120 would be our common denominator. So I could add them all up to find out to make sure that it's all added up to 1. Okay, so this is like your number 9, the classical probability distribution. Notice I haven't actually used this stuff yet. I told you about getting it, but I didn't use that yet. All I did was say, our same stuff we've been doing. If I'm choosing 3 of them without replacement, what's the probability that I get them? And so I can get 0, 1, 2, and 3. And then we just did it. Okay, now I'm going to back up and do the first 8 things, okay? Now I'm going to back it up. So I'm now going to go back to number 1. And again, number 1 is to find a container. You've done that. Number 2 is to make items that make 2 groups. I've got my M&Ms. Number 3 is decide what's white and what's black. We do that. I've got mine. They're just the colors of the M&Ms, and the whites are the colored ones, and the blacks are black. So I've got it. Find a way to select it randomly. So whether that's putting your hand in like this or pouring it out or whatever, make sure that you can select it randomly. Then we actually get to start the experiment. And what we're going to do now is actually do the experiment and see, are our results similar to this? We're going to find out empirically what happens. This is what we expect to happen. This is our, in theory, what should happen. But instead, we're going to now do it empirically. What actually happens when I do this experiment? And so we're going to make first we're just going to make a frequency distribution. And remember, we've done frequency distributions before, where again, we have the number of blacks. It's going to be my random variable. And we said that we can get 0, 1, 2, or 3 of those blacks. And again, in my notes, I think it only goes to 2. But it should go all the way to 3 because we can get 3 blacks. I don't know if the table got cut off or if I just left that off. But I noticed later that it's missing. So you should have a 3 on your table. And then what we're going to do is we're going to notice the frequency or the number of times this happens. So let me show you what I mean. So I'm going to go ahead and do it. I'm going to pull out 3 without replacement. I'm going to do it without replacement. 1, 2, 3. Okay, so what I got was a black, a blue, and a red, so these are white. So I got 1 black and 2 whites. 1 black. That's what I care about, is the fact that I got 1 black. So I got 1 black. I'm going to put a little tally mark here to let me know I got 1 black. For right now, I've just gotten it once. Okay, I'm going to do that experiment 10 times. I'm going to do 10 trials of the experiment. So there was 1. Now, I'm going to do it again. I'm going to pull out 3 things. 1, 2, 3 things. And again, I got 1 black. So I'm going to record that I got another one there. I'm just making a tally mark now, and then I'm going to make the frequency distribution here in a minute. Okay, I'm going to put them back in. That was 2 trials. Now I'm going to do it a 3rd time. So this is 3 trials. This is the 3rd trial. 1, 2, 3. And again, I got 1 black. I got 1 black. So I'm going to record that I got 1 black. So empirically, so far, it looks like I can only get 1 black. If somebody were to come along, they'd be like, you can't even get 3 blacks. That's not possible. Or it's not possible to get 0 blacks because we're just looking at what I've seen here in my trial. That's it. So, well, I've done it 3 times. I'm going to do it 7 more times. 1, 2, 3. Oh, look, this time I got 0 black. All white. So this time I got 0 black. All right, I've now done it 4 times. I need to do a total of 10 trials. That's right, it's 3 out of 10 so far is that probability. Or actually it was 3 out of 3. It was a full 100%. Now it's 3 out of 4. But now I'm going to do, but I am going to do it 10 times. Again, no black. So I'm just going to put a tally mark. That's 5 trials. By the way, I love the cards idea. There you go, Adam, use those cards. You can do 2 sets. You know, pick your favorite suit to be black. Like maybe your favorite suit is hearts. Make those black and everything else is white. Three of them, and I got 1 black again. So I've done 6 trials. This is trial number 7. Hey, I got 2 blacks finally. 2 blacks. That's 6, 7 trials. And there's 1 black. That's 8 trials. No, Zoe, I'm taking all 3 of them and putting them back in. I'm just counting the number of blacks each time. So all of them go back in every time. So it's without replacement because I didn't take it out and put it in, take it out and put it in. This was 1 trial. I took all 3 of them out. So this guy came out without replacement. Let me do it a little slower to make sure you understand what I'm doing. Okay, let me show you. I wrote that one down. So let me do the trial again. So here's another trial. I'm going to take it. I'm taking out 1. I'm not putting him back in. So this is what I mean by not replacement. In the with replacement one, you'll put it back in before you pull another one out. Then I'm going to take another one out and not replace it. And then I take the 3rd one out. I was doing that really fast, you're right. And now I look at them, I go, oh, there's only 1 black. So now I've done it 2, 5, 6, 7 times. I still need to do it 3 more times. And what do we expect to get? Well, looking at this right now, I'm expecting to get 1 black. I mean, it looks like that's more probable. And if we come back over here, it looks like it's more probable here as well for me to get 1 black. So it makes sense that I'm getting 1 more often. Okay, so I'm going to do it again. I'm going to pull out 3 of them without replacement. 1, 2, 3. This time I got 2 black. So I'm recording that 2 black. It wasn't what I expected. I expected to get 1, but I got 2. So now I've done 6, 7, 8, 9, 10. Oh, I've done all 10 of my trials now. 6, 7, 8, 9, 10. Yeah, I've done all 10 of my trials. Okay, so this is the data that you're going to turn in. One of the things you're going to turn in is the data collection. Here, I just collected my data. That's the record of your data collection. Now, I'm going to turn this into a frequency distribution. All I do is then write the numbers. I got 0 2 times. I got 0 blacks 2 times. I got 1 black 6 times. I got 2 blacks 2 times. And I got 3 blacks 0 times. This is the frequency distribution. So there's your number 7. Number 7 on the task says make a frequency distribution. I just did it. There it is. Now I'm going to make this into an empirical probability distribution. So now I'm going to do empirical probability. So if we had done that 24 times, we would expect our number over there to be 7. If we had done it 40 times, we would expect it to be 21. It doesn't mean that that it always happens, but that's how we compare this classical probability with the frequency distribution, or with our empirical. Okay, but we only did it 10 times. So here I'm going to take each one of these to make it into an empirical probability. Instead of doing frequency now, I'm going to make it into the probability. And this is empirically, well, I did it 10 times. So it's 2 out of the 10 times. So you remember when we did relative frequency back at the beginning of the semester? Well, this is that similar idea. It's out of the 10 trials. So probability is that same way, where it's just out of the total. So 6. Oh, that's the reason it's 2, Mr. Simpson. You're right. Because they're just taking out 2. You are exactly right. I was saying that. No wonder it was just 0, 1, and 2. So that's right. That's right. That's right. So on your notes, it does say 0, 1, and 2, and the reason is because y'all are just pulling out 2 black. So it shouldn't have that third. You're right. You're right. Whoever said that. You're exactly right. So yours won't have the 3 on there. Mine only does because I had 3 blacks. But you're only going to have 2 blacks. Okay, so now I had 6 out of 10. And this is 2 out of 10. And this is 0 out of 10, which is still 0. I really should simplify those to make it 1/5, 3/5, and 1/5. So we can kind of compare our empirical probability to our classical probability. You know, this is 20%. 20% is 2/10. If I come back over here and I say about what is that percent, well, you know, this is really close to 25. And if I wanted to get up to 100, 24 times, you know, pretend it's 25, we would multiply the top and the bottom by 4 to get up to 100. So it's about equal to 28%. So we expected to get 0 blacks 28% of the time, and we got it 20% of the time. So empirically, we were a little different from the classical, but, you know, not too far off. Here, this one is 60%. So again, to get up there, I need like 2 takes me to, I need 2.5 of these to get to 100. So if I multiply the bottom by 2.5 and the top by 2.5, so, well, 2 21s is 42, and a half of that is another 21, another 10, so about 52%. I'm just estimating about how much that was. You could, now that you're at home using calculators. I know you're using calculators, by the way. Oh well. While you're doing it, you could just take 21 and divide it by 40 and see what that percent is. I say it's close to 52%, in which case this 52%, that's pretty close to the 60%. And then multiply this one again by 2.5, because that gets me to 100. And so 2 of those is 14, and another 3 is about 17. Oops, 2.5. So it's about 17% of the time. And this is 20% of the time. So that's pretty close. That's pretty close. And then look how little this percent was. It was a teeny tiny percent that we should get it. We shouldn't get that very often. And sure enough, we didn't get a single one of them. So while it doesn't match it exactly in theory, we did empirically get pretty close to it. And if we did this experiment enough times, if we did it over and over again 1,000 times, our percentages of how many times we got whatever number of blacks, we would get closer and closer to that classical probability. So that's kind of the idea, is that as we get bigger and bigger, it gets closer and closer to that probability. Okay, but your job is just to turn in. Your job is to do this experiment and then turn in your empirical probability distribution, your data of you recording it, your classical probability distribution, your picture of yourself or your video of yourself doing the tasks, and of course post it on social media and tag Simpson_math, and you get a bonus point for that. And that's about it. I think that's it. Okay, so just real quickly, since I have 10 minutes, here's what I'm going to do. I'm going to do the same thing. I'm not going to make the classical distribution, frequency distribution, but I am going to go ahead and do the experiment with replacement, just so you can kind of see the difference of with replacement. So I'm just going to do the experiment and do 10 trials so you can see me doing that. So here my X is still the number of black that I get. And this first, I'm just going to do the frequency. So empirically, how many do I do? And notice how this is going to be different. And again, I can get up to 3, but Mr. Simpson's exactly right. Y'all's is going to stop at 2 because you only have 2 blacks. So earlier I told you yours should go up to 3. No. The reason mine's going up to 3 is because I have 3 blacks. Yours should stop at 2 because it has 2 blacks. That explains why. I was like, why is this off of there? But that explains why. I was confused earlier. Too early in the morning. Okay, so now let's do it. I still have, you can use those same containers, your same things that you had in there, and you can do, you can use it. This time I'll do it with pens and the pencils. So I'll use 3. I'm going to still use, well, heck, I'll just do it your way. I'll do it with two pencils and 8 pens, just like you might do. 1, 2, 3, 4, 5, 6, 7, 8. And so however you do it, you get a container, and then you, I don't know, some way that you can randomly do it. So maybe you just pour one out. And I got out a pen. I'm going to put that back. So in my case, my pencils are now the blacks. So I didn't get out of black. So far I haven't got out of black. But now I'm with replacement. So I got to put it back in. Now I'm going to pour out another one. And I got a pen. So far I haven't gotten a black out. And notice I'm putting it back in. And doing it again. And get out a pen. Oh, so I did not get a single black that time. So I'm going to put 0 blacks. All right, now I'm going to do it again. So that was trial 1. So each time, here's what I'm doing. I'm pulling one out. It's not, this is white. Put it back in. Pull one out. This one's white. Put it back in. Pull one out. This one's white. Put it back in. So I got 0 again. So notice with replacement, each time I'm putting them back in. Whereas without the replacement, I put it in my hand. All 3 of them at one time. But here I'm pulling it out, and then I'm looking at it and putting it back in. So that's a white, putting it back in. Pulling it out, looking at it, and putting it back in. Taking one out, looking at it, and putting it back in. Oops, pull 2 out. So again, I got 0 blacks. All right, so you get the idea, the difference between the with replacement and the without replacement. This one's not as good because this one's not very random. I can feel when I pull in if it's a pencil or a pen. So I don't like this one as well because it doesn't seem random. I like the one with the M&M better. So if you can find a way to make them pour out, like a cup or a kettle or a cup or something where you're pouring it out, it's probably better. But otherwise, just, do the best you can just to randomly choose. So it's a black, put it back in. A white, a black. I got 1 black this time. Put it back in. And a black. So I got 1 of my blacks. I keep calling the wrong thing wrong, but the pencils are, I got 1 pencil, 1 pencil, 1 pencil. I'm looking for how many pencils, basically. Okay, hopefully y'all get the idea. Everybody kind of understanding? Did I make it more confusing? Y'all all right? Help me out. You got this? All right, your job. If you haven't done the homeworks, go do classical day 1 homework. Then do the classical probability homework with the numbers. So the first day is just words. Make sure you're using and or. Then the next day you're putting the probabilities in it. Then do task 1, then do task 2, and there you go. Turn it all into Dropbox. Let me know if you're having any trouble. I'll be on Discord or Rimpson or A. Simpson or Jimpson or the Leech. One of us will be on Discord. You can ask us questions, or you can always text me, although I'm loving the Discord. So contact me if you're having any trouble. Yesterday we sat around in Pimpson's voice and did the homework. So you might want to, if you can, after the lecture video every day, pop on and just do the homework with everybody so that you can hear things. You can lurk and listen as I'm helping people, and it might help you on the homework as well. So, all right, y'all have a great weekend. Get it done, turn it in, and then I'll see you back here on Monday at 9:30. We'll live stream again, but I'll be around all weekend long. All right. Math made simple at Simpson Math. Y'all have a great weekend. Man, you can tell by Thursday I'm tired. Perfect. That's what you want to do. Lurk and listen. And just let me know if you need anything.